and I am going to share my screen with you. All right, so you know that we always start with, bam. Again, this is applied math. The enrollment code is on the screen. Most of you have been here before, so you have probably more than likely already enrolled in the class, and I thank you for that. So here's what we have today. We are going to talk about comparing data representations. Specifically, we are going to talk about histograms and box plots. And our objective, again, is to create graphic representations, but to also critically analyze what we see. What is the graph telling us? You know, what data is being displayed? And again, the standard comes from the state of Pennsylvania, what they expect to be taught in this class, so that my lessons align with it. Our agenda is we are going to have a community meeting. Then we're going to warm up. We're going to graph data in 2 ways. We are going to talk about how some of the characteristics of box plots, specifically because we've already talked histograms. And then we are going to talk about the things that we will look for when we are making comparisons. Then we're going to do a little practice. And then we will go over the assignment, which is, again, good morning, which again is due today by midnight. Okay. So let's get with it. So, community meeting question. Where do you see yourself in 5 years? So, we can look at it 2 ways. You can look at it, it is now 2020. So, where do you see yourself in 2025? Or you can look at it from a more personal level. You are somewhere currently between 16 and 21. So think about yourself between 21 and 26. Where do you see yourself? What are you doing? As I said in the last class, in 5 years, I will be 60. So I will be thinking about retirement, where I want to live. I want to, I'll be reviewing my finances to make sure that I can still live the life that I have grown accustomed to, even in retirement. So that'll be my focus in 5 years. So what you got, peeps? What you doing? 5 years.
I'm gonna be beyond stable.
Okay. You're gonna be beyond stable.
Yeah.
I ain't
Past
hold you.
stable. I'm be semi-straight.
Okay. What you got, Shot?
I ain't even gonna hold you. I fuck around, be a rapper or some shit. NBA player or something that make me a whole bunch of bread. I don't know.
Okay. So you okay. So you gonna have some coins.
Yeah, that's all you. That's how it is, no, dude. You gotta have the chicken. If you don't got the cheese, you don't got nothing.
All right, but okay. So 5 years, you gonna have the coins.
Yeah,
I'm there. So
yeah, you all there, very wealthy.
Okay. So think, and I like that. You said you want to be wealthy. You ain't say you want to be rich. You said you want to be wealthy.
Being rich is for people who plan to be poor.
Ooh, talk your talk.
Being wealthy is, well, you know what wealthy is.
Okay. Okay. All right, I like that. So again, we all have Mr. Luke on Wednesdays. So in Mr. Luke's conversations, he is trying to gear you all to think about, okay, you know your end game. What is going to be the path that you take to get to ensure that you get to that end game. So for those of you who are going to be wealthy, what are the steps that you are going to take in the next 4 years that when you get to year 5, you're going to be wealthy? Okay? You don't have to discuss it. I'm just saying for yourself. Plan your work and work your plan. If you are going to be wealthy, how are you going to get there? What is your vehicle? You know? And again, he's been talking about backwards planning. So that's what you would be doing right now. You know where you want to be. Now, think backwards to the steps that'll get you there. I'm going to see if somebody's chatting me. Okay, no chats. So again, think about it. In 5 years, where do you see yourself? Somebody might be thinking about going to the service. So you going in 5 years, you're going to see yourself in the military, and maybe you will be on foreign soil. You know?
For reference Hicks, I might think I might go to the service.
Okay. Okay. If you go to the service, you know what branch of the service you want to go to?
Yeah, the Army.
Okay. Why the Army? Why the Army?
Yeah, why? Because
Why the Army versus the Navy, the Air Force?
Because one, first of all, I can't be no Coast Guard because I don't know how to swim. 2, I don't like the rest of the field. I just like the regular Army. It gives you more. I feel as though it's gonna give me more structure. Like not saying that I got it now, but it's gonna give me a little bit more structure, you know, than the regular.
Okay. Anybody else? So we're gonna be straight on the cash 2 times. And we have somebody who might possibly be in a service. That's good. Again, it is just about getting you to think about what is next, because we know time waits for no man. In a minute, you're going to be 20. After that, you're going to look around, you're going to be 25. In a minute after that, you're going to look around, you're going to be 30. Time is moving, because think about it. Just a minute ago, you were in elementary school, and now, bam, you almost finished high school. You know, so time is a continuum. And again, you plan your work and work your plan. Okay, so I hope you all reach your goals, and if I can help you get there, I will. All right. So you can, again, respond to the community meeting question at any time. You can take it you can type it into the chat, but we're going to move on. And again, like I said, because I want to make sure that I get to the cool down. So we're going to do a review. So on Tuesday, I asked you all to graph the same set of data in 2 ways. And I didn't stress the third way, which was the dot plot, because the set of data that we had did not have any repetition. So there was not going to be too much activity on the dot plot. So that's what you see here. And again, the strength of a dot plot is that you can see every term in the data set. Okay, that is the beauty of the dot plot. You can see specific things happening. Okay. Even if you didn't see the data set ahead of time, if you're given a dot plot, you can easily create the data set. The box plot is a 5-number summary. It can give you an idea of certain things. It can tell you the range of the data, because the range is the distance between the minimum and the maximum values of the data set. So you can tell that. You can tell the middle of the data, or the median, because that is one of the 5 numbers. That is your Q2. You can also tell the spread or how far the middle of the lower end of the data is from the upper end of the data. Because again, you are finding the range, and that is called the interquartile range. Because remember, Q1 is the middle of the lower half of the data. Q2 is the middle of the data set itself. And Q3 is the middle of the upper portion of the data. So it's the median of the median of the data set and the median of the upper end. And those three values form the box. So again, if you don't need specifics, just need to get an idea of what the data looks like, you can possibly use a box plot. Because again, it is a 5-number summary of max, mins, and middles. Okay, the box is made up of middles. The box is in the middle because it's made up of the middles or the medians. And lastly was the histogram. The histogram is grouped into equal sized beds. Okay, so again, the beauty of good morning, the beauty of a histogram is a histogram can handle large amounts of data. So if you were trying to, let's say you worked for the city and city planning, and you had to talk about the population north of, I don't know, north of Lehigh Avenue. Well, that's a whole lot of people. So to display that data, you might use a histogram. And the beauty of the histogram, again, is you are grouping data together. So you can handle larger groups, but the downfall is you cannot speak to specifics. So if you don't have the data set ahead of time and you are just presented a histogram, you can't speak to specifics. You have to speak in general terms. So if we look at this histogram, we can say in general terms that our data set contains, good morning, our data set contains 3 terms that fall between 3 and 7. Our data set has 2 terms that falls between 8 and 12. Because remember, the upper end gets counted in the next group, okay, or in the next bin. So again, Histogram's beauty can handle large data. Excuse me, you can speak on general terms. Its downfall is you cannot speak about individual terms of the data set because you don't know. You don't know specifics. You only know about groups. And remember, your bins can be any width that you choose. It just has to be the same. So here we chose a width of 5. 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. 18 plus 5 is 23. Even though our data set only goes up to 21, but we still, even in that last grouping, we had to still make it the same width. Okay? So again, 3 different representations of the same data. And to step back at the box plot for a moment, the placement of your quartiles matters. Here, the middle of the data set is closer to the middle of the median of the upper portion of the data versus the lower portion. So that's why the line marking the median is closer to the right than it is to the left. But we're going to look at that. So now, here's what I need you to do for Lee. I want you to construct a histogram and a box plot using the data in front of you. I am going to give you to 11. I'll give you 8 minutes. I have 10:50. So that's 4 minutes per. And we are going to create a box plot. And a histogram.
Lisa,
Yes.
I'm about to leave off for work.
Oh, Lord. All right, can you at least watch the tape when I post it so you can do the pull downs?
Yeah.
All right, thank you, good sir. I'm gonna be looking because you know it'll tell me who viewed and who didn't.
What's it called? Miss Kelsey had just sent me the link so I could look at the YouTube videos and all that.
Exactly. Okay. Thank you. Good money. All right. So have a good day at work. Thank you so much for staying as long as you could.
Thank you for giving me the lesson.
Absolutely, darling. All right. So I'll talk to you later. And you know you will contact me anyway. So if you get stuck, contact me. Okay?
All right, I got
All right, take care, darling. Have a good weekend.
you too.
Thanks.
Everybody.
Here's your man. All right. I'm gonna see who else is here while I take roll. Oh, hey, Miss Kels. Hey, Ty. Ty. Hey, Nas. Nas. I got Sammy, got mine, got Tamara, got Quay. Okay. All right, he had to go to work. Mine is here. Quay is here. Where is Janae? She always comes on the wrong day. The day she should be here, she doesn't come. Okay, that's three. Good morning. How you doing? We are, oh, hey, Shanice Ben. Shanice, we are creating a histogram and a dot plot from this data set, and we are going to go over it in about 4 minutes. Okay, cool. So I'll talk to Sabrine. She had to go to work this good morning. All right, we're gonna take about 2 more minutes, then we're gonna have some discussion. I want to start with the box plot first because that entails a little more math than the histogram. What girl? All right, my loves, let's talk some math. Now, you will probably have to tell me about the angle. I do have the window open. I'm gonna stop my share so that you can sit. All right, so now, first things first, like I asked, we are going to start with the box plot. So you know, in a box plot, first things first, let's put the data in order. Somebody help me out.
89, 92, 93, 94, 99, a bean, 107, 111, 119, and 125.
All right. So now, remember, the box plot is a 5-number summary. First 2 numbers off the bat. Talk to me about the max and the min. What are they?
125 is the max, and the median is 89.
Wait. No, the minimum. You're so silly.
That's what you know that I made mistakes.
Yeah. All right. So the minimum is 89. And the maximum is 125. So we already have 2 of our 5-number summary. So now let's find Q2. Q2 is going to be the median of the data set. How many values are in the term? How many terms are in the data set?
10.
10. So when there is an even number of terms in a data set, how do we find the median?
If I add the middle two, 199 and 100, which is 199, and divide that by 2, which is 99.5.
Exactly. So ladies and gentlemen, remember, there are 10 terms. We come in 5 from the left. We come in 5 from the right. we add these two together. And we take their average. So your Q2 term, excuse me. So this is your Q2. So what is 99 plus 100?
$199.
Divided by 2. Life is not in whole parts. I want the whole thing.
There's no edge connection.
99.5.
Thank you. All right, so now in your data set, I want you to go back and put a little arrow or something, and you are going to add 99.5, because even though 99.5 is not a member of the data set, it is the middle. And now it has divided the data into 2 parts, the lower half and the upper half. So now if 99.5 is the middle, from 89 to 99, that's the lower quartile or the lower portion of the data. So now when we discuss finding Q1, we will be using this lower half of the data, because again, we just found, excuse me, damn. We just found the middle of the data set. We put that into, or we noted that in our data set. So now we have half of the data on one side. That's the lower half of the data. And then the upper half is 100, 107, 111, 119, and 125. So now, what is the middle or the median? What is the median of now the lower half of the data? The lower half are just these 5 numbers in green.
It's 93, wouldn't it be?
Yep. Because now that we have an odd number of terms, we came in 2 from the left, we came in 2 from the right, 93. So now that's that's the 3rd term for our box plot. And now let's look to the upper portion of the data. The middle of the upper portion of our data is 111. So now let's talk about the whiskers. How far, what's the distance between 89 and 93? What's 93 minus 89? You have 90, who? You have $93, you spend 89 of them. How much you got left?
It's
4.
4. Okay. So that means that that whisker doesn't have to be too long, because, excuse me, I left my marker in the kitchen. I went to get my tea. Sorry about that. Okay, so because the distance between 89 and 93 is short, it's only 4, we're going to have a short whisker. So we're going to move 89 over. Because, again, it's only 4 units between 89 and 93. Now let's look at the whisker on the other side. What is the distance between 111 and 125? You got $125, you spent 111. How much you got in your pocket?
14.
Ah, see, when I talk that money, y'all in order. So that means that whisker should be long. So the last thing, again, because remember, I said that we are going to have to be able to critically analyze the data, okay? So now, when we look at the placement of Q2, now this looks about the equal distance. So are we saying, no, let me take it back. According to this graph, we are saying that the distance between our Q1 and our Q2 is the same as the distance between our Q2 and our Q3. True or false? You have $99.50. If you spend $93, how much do you have left?
Wait, repeat that again.
If you had $99.50 and you spent $93, how much do you have left?
$650.
99, right?
Mm-hmm. Is it
$650.
$650 or $550?
650.
6. $6.
You sure?
Yeah.
Yeah.
Take off 50 cents. That's gonna make it okay. 650. So you got 650 here. What's the difference here? But you between $99.50 and $111. What's the distance?
Like, what you mean?
So if you had $111 and you spent $99.50, how much do you have left?
$11.50.
$11.50. So here we only had $6.50. Here, yeah, we would have $11.50, right?
Yeah.
Because Q2 is closer to Q1, we would have to move it over. Because in the long run, and we're going to talk about that when we talk about comparisons, that describes a specific distribution in a box plot. Because remember, it's going to be either skewed left, skewed right, or symmetrical. And the placement of the quartile markers matters. So for our graph, we would have put our Q2 closer to Q1 because, like you said, 99.5 is closer to 93 than it is to 111. Okay? Yes.
So I gotta get ready for work.
Okay. Well, you do your thing. Talk to me later.
All right.
So now for the histogram, remember, you have to group the data. So you have to create a table for your frequencies. So here you would have your bends, and then here you would have your frequencies. So this is we going into the histogram. Okay, so first, box plot, everybody's cool? You see how we got what we got?
Yeah.
Cool. So now for the histogram, because our numbers are in the 80s, the 90s, and the hundreds, for me, now again, remember, you can make your bend widths whatever you want. You don't want them to be too tight and you don't want them to be too large. So I made mine widths of 10. So I went from 80 to 90, 90 to 100, 100 to 110, 110 to 120, and then 120 to 125. And lastly, so that I can count 125, I have to go 125 to 130. So now, that's what your frequency table will start with. So remember, in the first bin, you count from 80 to 89. 90 gets counted in the next bin. So when we look at our data set, we only have one term that falls between 80 and 89, and that is the number 89. Right? So that's only 89. In the bin between 90 and 100, we count from 90 to 99. We have 92 to 99. So we had 92, 93, 94, and 99. So that frequency is going to be 4. Then from 100 to 110, we count from 100 to 109. We only have one term, and that term is 100. From 110 to 120, we count from 110 to 119. So we have, wait. Oh, I messed up here. Sorry, go back. 100 to 110, we have 2. Because it's 100 and it's 107. My apologies on that. Then from 110 to 120, we have 2. Because we have 111 and we have 119. Then from 120 to 125, we have none. And then from 125 to 130, we have 1, and that is the number 125. Okay? So that's what your frequency table should have looked like. And now you can make your histogram. Remember, you have to label your parts. So up the side is frequency. And you try again. You try to make them equidistant apart so that your graph will be pretty. Oh, that's what happened. Somebody was supposed to catch me. I changed the length here. Nope, that should have been 120 to 130 because I was like, that don't make sense. Okay, here we go. 1 goes there, and in there, $125 goes there. Okay, now that's better. Okay, because here I changed the width. I went 120 to 125, but the widths are 10. So I should have gone 120 to 130. So I made the adjustment. And again, in that bin, we still only have that one value of 125.